Hello everyone and welcome back to the machine learning class to continue with the module 1. In module 1 earlier class we have discussed up to the concept learning finding the S algorithm. So that is what is called as find S algorithm. So in the earlier session we have discussed like what are the drawbacks of finding S algorithm. So in that finding S algorithm, what we will be doing is we will be finding out only the maximal specific hypothesis. So only that maximal specific hypothesis we will be finding out in the find S algorithm, and it will be for only the positive examples. Only we will consider the positive examples and we will ignore the negative examples. So it will not take both the positive and negative examples, it will ignore all the negative examples and it will consider only the positive examples. So find S algorithm has that drawback, like it will not consider all sets of examples or all possible examples, only the positive examples it will consider. Now the next approximation algorithm what we will be using, the algorithm what we will be using is candidate elimination algorithm. Candidate elimination algorithm is used to overcome the drawbacks of find S algorithm, where we consider both the positive example and the negative example. So to derive this candidate elimination algorithm, or to see how candidate elimination algorithm works for both positive and negative examples, again to recall, X we call it as an instance, H we call it as an hypothesis, D we call it as a training example, C we call it as a target function. Then there is one more new entity called as version space, that is nothing but V of S, VSHD, that is version space, hypothesis, and D is data. H is hypothesis, D is data, version space HD. Now in the earlier class itself we have discussed, we have defined D is the data set and H is the hypothesis. So under this D training set or the data set, there will be number of instances which will be present. The instance is X, so in that instance X there will be number of attributes. So many attributes will be there. Again, if we consider the example what we have defined earlier, the same example of enjoying the water sport, then again we have instance X is like enjoying the water sport on a particular day with 6 different attributes. What are those 6 different attributes? Are like sky, air temperature, humidity, wind, water, and forecast. So these are the 6 various attributes. For those various attributes you have different values which will be represented as sunny, warm, normal, strong, warm, and same. The forecast might be same or change. So those are the values what we will be representing. So for those representing values we will then specify with which are general hypothesis or which are specific hypothesis. So that is maximal general hypothesis in H and maximal specific hypothesis in S. So general hypothesis in H we denote it as G, and maximal specific hypothesis in S we denote it as S. And one more important thing is we denote all the specific hypothesis as no value or empty value, and general hypothesis in the form of using question mark symbol, and the specific value we define them here whether it will be allowed or not, right? What will be the specific value? More specific it will be, right? Now before going to candidate algorithm, I would like to tell you about version space. What is version space? Say for example, you can consider an instance of an hypothesis, say hypothesis H, where you have iPhones. iPhones has got different versions, say 5C, 5S, 7, 8, 8 Plus, Pro, 6, 6S, etc. or 6S Plus and so on. Different versions of iPhones are available. So out of those different versions of iPhones, what training set you will be defining with? So you want a training set to be defined with D, training set, say 7, 8 and 8 plus. So 7, 8 and 8 plus are the three versions of the training set. What you will be taking those data set for as an example or else training example, and this is what you will be taking from the hypothesis H with different versions which are present in this instance X of iPhones. iPhones has got different versions, say 5C, 5S, 7, 8, 8 plus, Pro, and 6, 6S, etc., S plus and all. So out of that you are only taking 7, 8 and 8 plus training set. Now in between these two, the hypothesis and the data set, right, there will be an intermediate version. Intermediate version is nothing but the version space of this hypothesis H and this data set D. So what is that subset which will be derived from the hypothesis H is 7, 8 and 8 plus. So that version space 7, 8, 8 plus, which will be the subset of the hypothesis H, will be cross checked for the consistency. So it should have a consistency like whether all the training data sets are derived from the same hypothesis and whether it is present or not. If it is present, then it should be satisfiable. So it satisfies the hypothesis H of x is equal to 1. Otherwise H of x will be 0 if it is not satisfiable. Then we will check that whether it is satisfiable or it satisfies that it is present in the hypothesis from this subset, like 7, 8, 8 plus are the version space which are the subset of the hypothesis H, 7, 8 and 8 plus. So that satisfies, which are consistent and that satisfies H of x is equal to 1. That means it is a positive value. Now those are the training sets what you have derived or you are considering for the training. So for every training set, what we will be doing is we will define it from specific to general. So we will take the training set. Here in between there will be version space, right. What will be the more specific one? Specific one will be that empty value whatever you will be replacing with, then general one here at the bottom. So more specific will be going always upwards. Here in between we will be having a version space, and more specific always it will be going upwards, and general it will be always coming downwards. So for positive examples it will be from specific to general. That means empty value or no value to a general value. For negative it will be from general to specific value. That means generalization to a specific value. So always you will be initializing the specific values to the no value or empty value, and it will be initialized as S naught, and general value will be initialized as G naught with the symbol question mark symbol. So this is how we will be initializing the training data set for the example water sport. So in the water sport we have 6 attributes. Again I will be repeating the same. One is sky, air temperature, humidity, wind, water and forecast. So respective attributes will have the values sunny, warm, normal, strong, warm, same, and that will be a positive value. Second row is also a positive value, and third row it will be a negative value, and it will be a change that it will be a rainy day, so that you will be unable to go for playing the water sport. Next one is the fourth row. Again you will be defining a positive value, that means you can go for water sport on that particular day. Now coming back to the candidate elimination algorithm for the positive example. So for all the positive examples, if the data set D is a positive example, then remove from G any of the hypothesis that is inconsistent with D. So in the data set D positive example, we have to remove any inconsistent training set which is present in D. That means in the earlier example we have defined here So this is the data set. So if it is generalized like remove from G any hypothesis that is inconsistent with D. So if any of the data is inconsistent with D, say 7, 8, 8 plus are consistent in the data set D. So if any of the hypothesis which is not consistent, then you need to remove from the general hypothesis G. Then for each hypothesis which is yes in S means more specific, that is not inconsistent with D, then you need to remove that S from the S. That means small s means again that specific hypothesis has to be removed from that large hypothesis, right? More it is more or maximal specific from the maximal specific, and you need to add all the specific minimum generalization. Yes, this is minimum generalization and this is more or maximum generalization. So maximum generalization will be having all the minimum generalization yes in the hypothesis H. So such that all the minimum generalization will be in hypothesis H, which will be consistent with the D. So it will be consistent with the hypothesis D. So then otherwise you need to remove from maximum specific S from any hypothesis that in more generalization than any other hypothesis which is in S. S means more specific. Otherwise, if it is a negative example, then it will be like S will be more specific. S will be more specific means, so you need to remove from S any hypothesis that is inconsistent with D, and for each hypothesis G in G that is not consistent with D, so then remove G from maximal G, so that add the maximal G from all minimum generalization of small g to the hypothesis H, so that such that small s is such that consistent with hypothesis will be consistent with the data set D, and you need to remove from the G, so any hypothesis that is more generalization than any other hypothesis which is present in G. Now how to set an example or explain an example with respect to this elimination, candidate elimination algorithm. Say again, if you consider back the same example of water sport. So in the water sport example, first row, second row, third row and fourth row, that is x1, x2, x3, x4 will be taken as each example as positive example, again negative example and positive example and so on, and elimination algorithm will be applied. Say for the training example in the data set D, that is row x1, for the attributes of sky temperature, humid, wind, water and forecast, you have the values sunny, warm, normal, strong, warm and same. So x1 will be the row x1 will be positive. So for that you will be initializing the S0 and G0. So S0 with all the specific values, that is empty values initially, then for G0 it will be generalized question mark symbol, right. 6 values there for S0 and 6 values there for G0 will be initialized. Then if you go with first x1, for x1 if you go with specific values of S, you call it as S1. When you are writing the specific value for x1, you can call it as a specific value in terms of S1. I have written it in the short form instead of sunny, warm, etc. I have written is SW and so on for the sake of understanding. So S1 will be sunny, warm, normal, strong, again warm and same. Now for that, so G0 has been already initialized to the question mark symbol, that is nothing but generalization. So for this specific S1, specific hypothesis S1, all the specific hypothesis has got the value which is very specific. So sunny is very specific, no other change, warm is very specific, no other change, normal is very specific, no other change and so on. So all the values are very specific and no other change is there. That means, so for the generalization of G1, again you can replace them as generalization form in the form of a question mark symbol, because S1 is more specific, then it can be generalized. So when you say it is more specific, then it can be generalized. Next, if you consider the example for second row, that is x2, then it will be defined as sunny, warm, high, strong, warm and same. Still it is a positive example. On that positive day you can go for enjoying the water sport. But the only change is with respect to humidity. Humidity will be high instead of normal. In x1 it is normal, in x2 humidity will be higher. So S1 remains same and implies to the S2 sunny, warm and high is the humidity instead of normal. So that is the change. What we will be doing is we will be replacing it with a generalization symbol, that is question mark symbol, and rest of the things remain same. So S1 will be remaining same with the more specific values, and S2 will also remain with most of them except third value, rest of them will remain same. So only that first and second values will be same and third value will be replaced with question mark symbol, that is with respect to normal and high, and rest of the 4th, 5th, 6th values will be remaining same. Now the generalization of these specific values will be again already generalization of S1 is G1. G1 is what? G1 is all the 6 values are question mark symbols. Now if you generalize the same thing, anyhow a specific value 2 here it is already generalized, one of the value is generalized. So now G2. So G2 will also be generalized in with all the question mark symbols. So in turn G1 and G2 both of them have been generalized with question mark symbols. Now we consider the third row, that is x3. So if you go to the next row, that is the example of x3. x3 is rainy, cold, high, strong, warm and change. These are the values associated with the attributes in x3. Now S2 is already we have defined with respect to one change, that is high and normal here. Now if you write it for S3, right? So if you write a specific value for S3, then it will be like almost same with respect to S2 and S3. So S2 is very specific, like it is sunny, warm, it is high or normal, and again it is like strong, warm and same. Similarly S3 will be more specific, right? It is rainy, cold, high, strong, warm and change, right? So this it will be almost similar to that. Now what we will be writing with generalization for S3 will be different, whereas generalization of G2 will remain same here, and the generalization of S3 will change here, right? It will be sunny here instead of rainy. So when you have sunny here instead of rainy, then rest of the things will be generalized. Then first thing will be, or first value will be generalized again here, and you will keep varam here, right? Varam, second value as more specific. That means what we will be doing is, say in S1, specific value is S sunny, and second value is varam, which is also more specific, and it has been generalized in G1 and G2. Both of them has been generalized, but S1 and S2 are same. S1 and S2 are same. So when you are writing S3, again when you are making it to G3, right? So when you come to S3 with a more specific value, then you will be having values compared with rainy, cold, high, strong, varam and change. So that is what you will be doing. So that means the comparison will be generalized. So when you are generalizing it, then you will be comparing it with S1 and S2, and it will be appropriately written for specific value of S3. That means it will be sunny and rest of the values are generalized. It will be varam and rest of the values are generalized, and it will be same, the forecast and rest of the values are generalized. Now for the last example, or the last row, that is X4, if you go for the last row, then it will be sunny, varam, high, strong, cool and change. Then it will be a positive day going for water sport. So then it will be a positive day going for the water sport. Then again S3 will be remaining same, means SW question mark symbol SWS, and you will write a more specific value for S4. So again if you write a more specific value for S4, then it will be sunny, varam, and again generalization, and again it will be strong, and another two values will be generalized. So another two values will be generalized for S4. So once you are generalizing it for S4, then you need to write the generalization for G4, right? So generalization of G4 will be S and rest of the values will be generalized, and again here varam and rest of the values will be generalized here. So this is the example how we will be generalizing from S1 to S4, right, by using the candidate elimination algorithm, considering the all positive and negative examples. Unlike in find S algorithm, we will be ignoring the negative examples and we will be considering only the positive examples. So here we need to concentrate more on examples and see that like how candidate elimination algorithm will work. So until and unless you practice it better, so then it will be little bit difficult to understand the examples with respect to specific values and general values. That means specific hypothesis and general hypothesis of S and G. Okay. After candidate elimination algorithm, the next one is inductive bias. So what is inductive bias? So in inductive bias, what if the target concept itself is having the hypothesis space or not? That means what if the target concept is contained in hypothesis space? So what is the hypothesis space that will be contained with the target space? Otherwise, whether it will include every possible hypothesis, whether the hypothesis space will be including all possible hypotheses, or else whether the size of the hypothesis space influence the number of the training set. So whether the training set number will influence the hypothesis space, right? So size of the hypothesis space, that is what we have discussed in the earlier example of iPhones. So in iPhones you have so many versions like 5C, 5S, 6S, 6S plus, 8, 8 plus, 7 and so on. So in your training set you will be considering only 7, 8 and 8 plus. So that is what is your data set. Say for example 5S or 5C is not present in your data set, and it will be an additional hypothesis or the data set which will be used in that hypothesis space, so which is not present. So that will be increasing the size of the hypothesis space, which will influence the number of the training data set. Regarding that, there are two specific categories. One is biased hypothesis space, another one is unbiased hypothesis space, or you call it as unbiased learner. So biased hypothesis space means, so far in the example of water sport, we have the 6 attributes and for those 6 attributes we have the respective values, so the specific values. So for the attribute sky, we have the specific value, either sky will be sunny or rainy with respect to all the x1, x2, x3 and x4 instances. So in the x1, x2, x3, x4 instances, we have the specific values for sky is either sunny or rainy. Now what if that another instance, another value will be like cloudy for sky, where again you will write the values for that instance will be sunny, warm, normal, strong, cool and change, and again it will be positive for the attribute sky. Next, you will be writing one more value, a specific value for that attribute sky will be cloudy. Rest of the things will remain same, that is warm, normal, strong, cool and change. And again the x3 which is already present there is sky will be rainy, warm, normal, strong, cool and change. So these are the specific values which will be already present, that is the first one and the last one. Now in the in between, another case you will be taking up is sky will be cloudy. So even though the sky will be cloudy, still if you say it is a positive day for going towards enjoying the water sport, yes, then it is acceptable. So there will be one more training data set which was not there in the hypothesis, has been influenced, and the size of the hypothesis or the data set has been increased. So hypothesis space will be increased. Now such that it will become more general or over generalized. So how it will be more general or over general means, these things are already like warm, normal, strong, cool, change are there, right? So these are the specific values, and this is the general value which is changing. So sunny is changed from cloudy, and again sky will be from cloudy to rainy. These are the general values, specific values which will be changed. So it will be generalized. So the specific values will be generalized, means it which will be going to the bottom for generalization. So specific hypothesis will be like generalization of first value sunny, cloudy and rain to the generalization symbol question mark, and rest of the specific values will remain same, warm, normal, strong, cool and change. So this becomes over generalization of these specific values in biased hypothesis space. Now for that if you check with unbiased learning, or if you go with unbiased hypothesis space, then it is something called as a power set of that instance. That means set of all the subsets of set X, then it is called as the power set of X. In the sense, there will be 6 attributes with 96 instances. So for 6 attributes there will be 96 instances. Now it is like power set means power set of X will be to the power of 2, that means 2 to the power of 96 instances. So 2 to the power of 96 instances will be defined. That has to be defined means, now earlier we will be defining with only starting with the instances sunny and so on, the generalization. Now versus you need to add one more that is sky will be cloudy, and again the same generalized instances will remain. So every time it will become 2 to the power of 96 instances, that means it becomes power set of X. This is defined as unbiased learning. The last one is futility of biased free learning. Futility means the uselessness or the less used biased free learning. So uselessness of biased free learning means it is something called as there are two systems. One is inductive system and another one is equivalent deductive system. In inductive system you will be introducing or having CEA, candidate elimination algorithm. The training examples with new instances will generate the classification of the new instance, or it will say it is unknown. So for any training set or training data examples, what we will be giving, for that you will be having a new instance. So for that, a candidate elimination algorithm using the hypothesis space H, we will determine the inductive system like classification of new instance will be done. Otherwise, we will say it as do not know. The same thing if we apply with equivalent deductive system. So theorem theorem prover will say like training examples and new instances will have an assertion of H contains, that is the hypothesis H will contain the target concept, where the theorem prover will then again give the output like classification of new instances, or there will be no output, or that means do not know. Do not know, it will not be classified. So inductive system again will be using the candidate elimination algorithm using hypothesis space H and will be classifying the new instances. If not, it will say do not know. Again here in the equivalent deductive system, along with the training examples and new instance, you need to provide an hypothesis space H for the target concept. Then it contains the target concept here. So theorem prover will say like, okay, classification of new instance will be done, and otherwise it will be do not know. So overall these things will cover, these things are covered in module 1 of machine learning. Thank you.